This is Zhaorong Yang.
And this is Eunice Lee.
Today we're gonna talk about Hadoop. First, welcome my partner to talk what is Hadoop.
Hadoop is an open source project that allows users to store, process, and model unlimited data. It uses clusters of low-cost servers to work with large data sets and is infinitely scalable. Hadoop became synonymous with the big data movement early on. Hadoop is best described as a framework of tools that provides an environment for large-scale parallel processing. Its structure has two components: one, MapReduce, and two, HDFS, or the Hadoop Distributed File System. Using a distributed model structure, Hadoop can be used on one computer or up to thousands of computers based on the processing speed required by the user. Hadoop uses a grid computing technique and maps tasks across clusters of machines and splits them into smaller tasks before reducing the results into one master calculation. Most data stored in Hadoop Distributed File System is published as tables. Hadoop was created by two former Yahoo employees who donated the project to Apache, a large open-source programming community. Development of Hadoop began in 2006, and some of its biggest initial users included Facebook and Yahoo. Hadoop was inspired by Google's MapReduce programming model. Programming languages supported in Hadoop include Java as well as Python, C++, and other languages. The Hadoop framework itself is written in Java.
Let us deep dive into the Hadoop architecture and its components. HDFS is a reliable distributed file system that provides high throughput access to data, while MapReduce is a framework for performing high-performance distributed data processing using the divide and aggregate programming paradigm. HDFS consists of two major parts, the name node and the data node. The name node is the commodity hardware that contains the Linux operating system and the name node software. The system having the name node acts as the master server and it does the following tasks. First, it manages the file system namespace and then regulates client access to files. It also executes file system operations such as renaming, closing, and opening files and directories. For every node in a cluster, there will be a data node. These nodes manage the data storage of their system. Data nodes perform read-write operation on the file systems as per client request. They also perform options such as block creation, deletion, and replication according to the instructions of the name node. The file in a file system will be divided into one or more segments and stored in an individual data nodes. These file segments are called as blocks. In other words, the minimum amount of data that HDFS can read or write is called a block. The original version of MapReduce involved several component daemons, including job trackers, which are the master node that manage all the jobs and resources in a cluster. And then the task trackers are agents deployed to each machine in the cluster to run the map and reduce tasks. And the job history server is a component that tracks complete jobs and is typically deployed as a separate function on with job tracker. MapReduce is designed to match the massive scale of HDFS and Hadoop, so you can process unlimited amounts of data, fast or within the simple platform where it's stored. So let's take a simple example of MapReduce. Suppose there's a task that you need to list and count the number of times every word appears in a novel and split the task among 26 people. So each takes one page, writes a word on a separate sheet of paper, and takes a new page when they are finished. That's how called the mapper aspect. And when all the pages are processed, users sort their single word page into 26 boxes, which represent the first letter of each word. Each user takes a box and sorts each word in the stack alphabetically. That's called reduced aspect of MapReduce. So what is Hadoop good for? First, it's good for processing really big data. In conventional methods, companies had to spend a considerate of their benefit to storing their data if it had terabytes or petabytes of data. Hadoop stores entire raw data generated by the company. It is easier to refer to raw data if the company intends to change their direction of process in the future. What's more, since the tools used for the processing of data are located on the same servers as the data, the processing option is carried out on a faster rate. And it's also good for storing a diverse set of data. Hadoop can store and process any file data, plain text files or binary files like images, and even multiple different versions of some particular data across different time periods. Hadoop saves this time as it can derive valuable data from any form of data. It also has a variety of functions such as data warehousing, fraud detection, campaign analysis, etc. Another key advantage of using Hadoop is its fault tolerance. When data is sent to an individual node, that data is also replicated to other nodes in the cluster, which means that in the event of failure, there is another copy available for use. However, Hadoop definitely has some cons. Due to its high capacity design, the HDFS lacks the ability to efficiently support the random reading of small files. As a result, it's not recommended for organizations with small quantities of data. Hadoop is also missing encryption at the storage and network levels, which is a major selling point for government agencies and others that prefer to keep their data under wraps.
The open source platform of Hadoop has allowed major companies to embrace this framework of tools and tailor the technology to the firm's specific business model. For example, in 2010, Facebook Messages was the latest version of the social media network's attempt at creating a real-time messaging application. The Facebook Messages infrastructure needed to be able to handle millions of short sets of temporal data. They ultimately settled on using HBase, a distributed database, for its scalability and ability to warehouse petabyte-sized datasets. HBase offered features such as replication, end-to-end checksums, and automatic rebalancing. Another example of Hadoop use is the Royal Bank of Scotland. The bank focused on improving customer satisfaction after suffering during the global financial crisis. To do so, the Royal Bank of Scotland sought to use Hadoop to drive consumer insights. This helped the bank quickly assist customers when they faced problems and also provided tailored recommendations for customers to drive up profits. This was primarily done using Cloudera, a popular distributor of Hadoop. Other global companies that use Hadoop are Amazon, Alibaba, Google, New York Times, Twitter, and Yahoo, to name a few. Thank you for viewing our presentation.